the session. So let us start today's session. And first of all, I would like to mute you all so that the effective running of this session could be possible. So today, our session is about uh, two groups mean comparison as well as more than two groups mean comparison. So we will discuss in detail how the mean comparison could be done. And before that, I would like to share uh, the data set that we may use as a drill as well as for learning the process. So I would like to share the data set in your chat bot and the chat box. Just a minute. This data set would be helpful for you by learning on hand whatever the concept you may learn today. You will be able to find out how the analysis was performed, how the process was done. So kindly download this data set and I will let you know how and which file need to be used with each process. So let us start today's part. Previously, we have discussed about single group comparison where we have learned the process through measured at once and measured twice. And today we are going to learn the procedure of two group analysis uh, uh, with the learning objective of mean comparison. So, quantitative primary data analysis, it is a fourth day on the basic level. Myself, Zahid Bashir, your trainer for quantitative primary data analysis. And these are our learning objective for today. Previously, we have discussed about single group mean comparison that was completed on 31st December 2023. Today, we will discuss about two group mean comparison as well as more than two group mean comparison. Both of them are some advanced form of single group mean comparison. Next, what will we discuss in two or more than two groups mean comparison? The session one will comprise of 6 p.m. to 7:30 p.m. That includes the process using SPSS, two group mean comparison. Then the session two will comprise of 7:40 p.m. to 9:30 p.m. We will have a 10-minute short break, and we will consider after the break more than two group comparison. What will we discuss about two group mean comparison? In statistical analysis, a two group mean comparison typically refers to the comparison of mean between two different groups. If we have two different groups, like in single group comparison, we may have either the measured at once or measured twice, where we have paired group comparison. But in terms of two different group comparison, we may have some independent groups. So this analysis aims to determine whether there is a statistically significant difference between the mean of two independent groups. Means both groups do not depend on each other. Neither the data may comprise of dependency on any group. So this type of comparison is common in various fields like social sciences, medicine, and business. Uh, what do we mean by independent groups? Two independent groups refer to the two set of observations or entities that are distinct and unrelated to each other in the context of a particular study or analysis. The term independent implies that the measurement or characteristics of one group are not influenced by or related to the measurement of the other group. In statistical terms, the group are considered independent when the values in one group are not systematically linked to the values in the other groups. Means here we will be dealing with the independent groups where the values of one groups are not related or dependent on the other groups. So examples of two group mean comparison, how will it be applied in different, some of me asking about sharing the data sets in WhatsApp group. So please wait. First of all, uh, someone has already shared it, but I would like to share the data set to some mail members to other WhatsApp group. So please wait. All right. I would request from some of the participants to please share the downloaded data set that I have shared in the chat box, to please share the data set in the WhatsApp group, because during the session it would be quite difficult for me to answer the WhatsApp chat. Come back to the topic again. Examples of the two group mean comparison in different fields. How we will exemplify that the process requires the two group mean comparison. For example, in medicine and healthcare, comparing the effectiveness of two different medicine in reducing blood pressure. Some of the people normally suffers from blood pressure in their normal routine and from a lot of years, and the pharmacist or even the doctors recommend two different types of medicines for reducing the blood pressure. So the researcher may be interested in determining if there is a significant difference in the mean blood pressure reduction between the patient treated with medicine A and those treated with medicine B. So if a person is treated with medicine A and he got his blood pressure is significantly reduced, and the patient that is being treated with another medicine for reducing the blood pressure, and that medicine does not may not prove to be very effective. So we can we can conclude that medicine A may be more effective than medicine B. So in these type of comparison, two group mean comparison would be applied. In the similar way, in education domain, you may be interested in assessing the impact of two teaching methods on student exam score, like the student treated with teaching method A. How do they perform in their exam, or how do they perform in their normal test procedure? What is their score? What is the impact of their score? So you can analyze how the significance difference could be concluded over here. So compare the mean exam score of students who receive teaching method X with those who receive teaching method Y to identify the more effective approach. So you can see that two types of interaction, or two types of interaction terms would be included here: teaching method A and teaching method B. So, in domain of psychology, we may be interested in investigating the impact of two therapy approaches on reducing anxiety levels. So, different types of therapies, how would they help to reduce the anxiety levels? So, compare the mean anxiety scores of individuals who underwent therapy A with those who underwent therapy B to determine the more effective intervention. In the similar way, we may be interested in the finance and economics domain, and we would like to know the impact of two investment strategies on portfolio return. Like we are interested in comparing the mean returns of portfolio following investment strategy A with those following investment strategy B to identify the more profitable approach. In the same way, in terms of market research, we may be interested in analyzing the effectiveness of two advertising strategies in generating the sale. We may need to compare the mean sales figures for product promoted using strategy A versus the strategy B to understand which strategy is more successful. Obviously, the strategy that may generate the more sales figure may be more effective in terms of sales figure. And the last one, but not the least, because there may be a lot of more examples, but I would like to discuss main examples. So, for example, environmental studies. I would like to know evaluating the effectiveness of two pollution control method in reducing air pollution. uh, and we may be interested in comparing the mean levels of air pollutants in areas where control method X was applied versus control method Y to assess their relative. I think there is a question from someone. No, nobody has raised the question. I thought that someone asking the question, but no one. Okay. Well, we go to the next part. The next part is regarding how different types of techniques would be applied when we are considering two mean comparison methods. Normal data with equal variance, that is the case one, when we are considering the independent sample t-test. Normal data with not equal variance, that is the case when independent t sample would be applied, and not normal data when we are discussing with Mann-Whitney U-test. In the first two cases, the only difference is with respect to equal variance approach. We are dealing with the data which is normal data. With equal variance, we are dealing with the normal data with not equal variance, and we are dealing with not normal data. So, in two group mean comparison, we may be interested in the three categories of data set. How would we consider two group mean comparison? There are three steps involved. First of all, we need to check the normality of the data, decision about appropriate test based on normality, and then we need to test the comparison of mean based on appropriate test. So these are the usual test procedure that would be applied when we are dealing with the two group comparison. So SPSS procedure for deciding appropriate test. How would we decide uh, about the SPSS procedure? First, we need to check the normality, like we go to analyze, then we go to non-parametric test, then we go to legacy dialog box that we have already did. Then we choose one sample KS. Then we will put our sample data of continuous variable test variable list, and we will press OK. If asymptotic sig value is two tail, it means greater than 0.05. The data is normal, and we will consider the parametric test approach, which is independent sample t test. And if the in case of parametric test, when we are applying these independent sample t test, we may have further two options. The first option is when the Levine test indicates the value, the sig value greater than 0.05, we may consider that equal variance is assumed. In case where Levine test shows a value, a sig value less than 0.05, we may consider it as a unequal variance. In other cases, if our asymptotic sig value is less than 0.05, that data is not normal, and we will go to the non-parametric test, that is Mann-Whitney U test. So first we deal with the normal data with equal variance. When your data fulfills the normality assumption as well as equal variance assumption, the test appropriate for two group mean comparison of such data would be independent sample t test. So when your data is normal and you need to compare your two groups along with equal variance, you need to test the independent sample t test. So what is independent sample t test? The independent sample t-test is a statistical method used to compare the mean of two independent groups for one continuous variable. There should be a one continuous variable that would be considered as your dependent variable of the study. To determine if there is a statistical significant difference between them, this test this test is applicable when the observation in one group are not related or paired with the observation in the other group. The independent sample t-test is widely used in the various fields to compare the means of two distinct groups. Such comparing the test score of students from two different schools or evaluating the effectiveness of two different medical treatments. Assumptions of independent sample t-test. The first assumption is that the observation in each group must be independent of each other. They should not be related with each other. This means that the value of one observation is not influenced by or related to the value of any other observation in the mean group. The second is normality. The population from which the samples are drawn should be approximately normally distributed. If the sample size are large, typically n greater than 30, the central limit theorem often allows for the assumption of normality to be met. It means that if your number of observation are greater than 30, you does not need to check the normality. If your number of observation are less than 30, you need to check whether your data is normal or not. So in case when we start the analysis through SPSS, we will check whether our data is normal or not. Then homogeneity of variance, because equality of variance is assumed in this test. So we will check whether the variances of two groups should be approximately equal or not. This means that the spread or variability in scores within each group should be similar. Violation of this assumption may affect the accuracy of the t-test. So if the test is violated, of the equal variance assumption is violated in this case, it may affect the accuracy of the t-test, especially if the sample size are small. So we need to check it. Then what type of data and sampling techniques we are going to apply in this method. The data for dependent variable need to be continuous. It means either they are interval scale or ratio scale that need to be compared with two independent categories of groups, like two categories of IVs, and the samples are drawn randomly from both groups population. So we can conclude here that comparison of common continuous variable with two different categorical variable will be done over here. Examples of scenario with independent t-test application. For example, comparing the average score of students who attended two different teaching methods to determine if one method is more effective in improving the academic performance. To investigate whether there is a significant difference in the recovery time of patient who receive two different medication for the same medical condition. To assessing the mean sales performance of two distinct sales teams to determine if one team constantly outperform the other in terms of sale figures, to analyze the mean anxiety level of individuals who underwent two different therapies interventions to identify the more effective treatment. And then we will also see to compare the average running times of athletes using two different training regimens to determine if one regimen leads to significantly better performance, and evaluating the average return on investment for two different investment strategies to identify which strategy yields higher returns. Here is an example for our SPSS analysis. For example, an analyst at a department store wants to evaluate a recent credit card promotion. To this end, 500 cardholders were randomly selected. Half received an ad promoting at a reduced interest rate on purchase made over the next 3 months, and half received a standard seasonal ad. So it means that we are dealing with a group with two different groups. One group is basically receiving the standard ad promotion, and the second one is receiving the promotional ad. So how they have spent over the last 3 months, how much they have spent over the last 3 months. So here are two categories and one continuous variable. The spending over the last 3 months is their continuous variable, while we are dealing with the categorical variable. First category is related with standard seasonal ad, and the second category of the people related with promotional ads. So, what we are interested to find out here, does a credit card promotion offering a reduced interest rate on purchases for the next 3 months result in a statistically significant difference in spending behavior compared to the standard seasonal among the randomly selected card holder at a department store? It means we are interested to find out whether these two categories of people, one who is receiving the standard ad program and the second is receiving the promotional ad program, whether there is a significant difference in their spending, in their 3 months spending over the last 3 months or not. So we are interested in it. You have a data set in your two group analysis. You might have a file with normal, and I would like to open over here. Just a minute. You might have a file named two group mean comparison I have shared. Uh, in two group mean comparison, you might have a subfolder with normal with equal variance. So in this, you need to open example1.sav. Just open it, and in the meanwhile, I would elaborate the remaining part of it. So, by learning this example, you would be able to learn how the normal data with equal variance would be treated in SPSS. So, first you need to what you need to do is you need to develop your hypothesis. Your null hypothesis would be there is no statistically significant difference in spending behavior between the card holder with ad promotion like group 1 and those who receive the standard seasonal ad, that is the group 2. So we would consider that there is no statistical significance difference between these two groups. Our alternative hypothesis would be there is a statistically significant difference in spending behavior between card holder with an ad promotion and those who receive the standard seasonal ad. So, in alternative hypothesis, we may be interested in the reverse of this effect, and this is basically the statistical formation of your hypothesis. Like in null hypothesis, we may claim that the first group is equal to the second group. It means there is no significance difference between both groups. While in alternative hypothesis, we may state that the first group is different or not equal to the second group. This is the hypothesis formation of those groups. So what steps we may be interested in SPSS? First, we need to check the normality of the data. Then after if the normality is confirmed, we need to apply the independent sample t-test. Then we need to check whether the equality of variance assumption is fulfilled or not. So these are the three steps when you are checking when you are considering your normal data for two group mean comparison. So here it started. You need to go to the analyze, then you click on non-parametric test, then legacy dialog box, then one sample KS. This is the procedure for normality testing. Then you at the next part, you would go to here. Here you will select the continuous variable from your data set, like your spending, your 3 month spending as a in the form of your test variable, and you just need to click OK. then the result will appear like this. You can see that the asymptotic sig value, which is two-tailed, is higher than 0.05. If this value is higher than 0.05, it means your data is normal. So when your data is normal, you may consider the next procedure. That is, you need to interpret how the normality of test and decision about appropriate tests could be considered over here. Interpretation of normality includes, since the level of significance asymptotic sig value, which is two-tailed, is equal to 0.200, which is greater than 0.05. Therefore, the normality assumption is fulfilled. So, decision about the appropriate test. As the data is normal, therefore, independent sample t-test will be used for testing the hypothesis. However, we additionally need to check for equality of variance. It means we still have to check whether the equality of variance is fulfilled or not. So it will be checked in the one sample t-test. Paired sample t-test. So what is the procedure for applying the t-test for independent sample here? You need to go to the analyze button, then you need to select the compare means, then you need to select the independent sample t-test, and again on the next part, what will you do? The next part is you need to select your grouping variable, like different categories that you are dealing over here, the different categories of the card holder uh, as a grouping variable. Then you need to select your spending as a test variable. After putting it, you need to check what are your groups codes. So how can you check, how can you define your groups? So you need to click to define your categorical variable group. So how can you check what are the codes, what are the actual codes? You need to check your codes from your variable view. You need to check by clicking on the value label column in the respective row, and you find out that we are indicating 0 for standard group, for standard card holder group, and we are indicating 1 for new promotional group. So these are the codes which are required when you are putting in the defining group. So you need to check from here, click here to identify the categories of your independent variable. Then you need to know, you need to note down these number for defining the groups in independent sample t-test for your data set. So you put these number over here. As a group 1, you will indicate 0. As a group 2, you indicate 1. Remember one thing, if you put the numbers different from here, you will face some error in the analysis procedure. So always check the numbers from the categories of variable view of your file. Your numbers should be same as you have putting over here. So if these numbers are different, like if I put instead of 0 and 1, if I put 1 and 2, it will give me some error. So you need to check it. So these are the standard ad. This is the code for standard ad. This is the code for promotional ad, and you will click OK. And then after putting it, you need to click OK again for the next screen, and you will find an output table like this. Here you can see uh, the average value of their spending. Like in case of new promotion, the people are 250 in numbers and they are spending more as compared to standard card holders. So the card holder with standard promotion or standard ads, they are spending $1,566.39, while the card holders with new promotional ads, they are spending 1,637.50 in the last 3 months on average. So we can say that the card holders with promotional ads are spending more on average as compared to the card holders with standard ad. Next, we need to check whether this difference is is significant or not. So we can check in the second table, especially in sig two tail value, if this value is greater than if this value is less than 0.05, we may conclude that the difference that is placed in terms of mean in first table is basically significantly different, or this difference is significant at 5% level. So next we can also verify it from the t value which is placed before the degree of freedom column. This t value should also be greater than 1.96. So the t value as well as sig value indicates that the difference placed over above is basically significant at 5% level. So what we can conclude over here, there is a significance difference between the average spending of card holder with standard ad and promotion ad. Uh, the last thing that we would see over here, that is Levine test for equality of variance. If this value is greater than 0.05, we may consider it that there is an equal variance between both independent groups. So when this value is greater than 0.05, this is basically the part where Levine's test for equality of variance is assumed. So if this sig value is greater than 0.05, it means there is a equal variance between both independent groups. So if this value is less than 0.05, we may consider it that Levine test for equality of variance is not fulfilled. But in our case, it is fulfilled. So interpretation of independent sample t-test in APA style, how we would interpret this result. The result indicates that there is a significance difference. First, you need to put how much your degree of freedom is along with t, and the t value, then you will place the p value in the mean spending of card holder with standard ad and with promotional ad. The finding also indicate that card holder with promotional ads are spending more. We have seen in the previous slides that the card holder with new promotional ads, they were spending more on average as compared to the card holder with standard ad. So we may highlight this in interpretation, that the finding also indicate that card holders with promotional ads are spending more along with their mean value, which is 1637.50 with a standard deviation of 356.70 on average as compared to the card holders with standard ads, which is mean is equal to 1566.39 with a standard deviation of 346.67. All these values are extract from the previous table. The magnitude of difference in mean is equal to, that is mean difference. You can also find out the mean difference. You can see over here, this is the mean difference. This value is considered as a mean difference, and how we can compute it, just simply subtract the second group mean value from the first value, and you will find out this. So this is the mean difference between both groups, and this mean difference is significant between both groups. So we will also highlight this value over here. So mean difference is equal to minus 71.11 with a 95% confidence interval ranging from this to this. So therefore H1 is accepted, because in H1 we are considering that there is a significant difference between both groups. And furthermore, you also can see uh, an effect size table over here. So you need to check the Cohen's D as a effect size, and you need to consider the half of this value. So at present there is a small effect. I will share basically the standardized table for a guideline purpose, that how will you decide that whether there is a small effect there, whether there is a large effect, or whether there is a very large effect. So you will decide from the point estimate table. So here the effect is very small, so we can say that there is a small effect of this spending on mean comparison. This is how we can interpret. So next we will consider the next example. But before that, I would like to do the whole procedure in front of you, that how will we find out uh, each and everything, and how will we conclude. So first you need to understand the statistical procedure of a two group mean comparison. First you need to check the normality of the data, but remember one thing. If your number of observation are greater than 30, you don't need to check normality. But if in case if your number of observation are less than 30, you need to check the normality. For your consideration, for your point of learning, I would like to elaborate how the normality will be checked. It is the procedure that I have let you know in the last session. You need to go to non-parametric test. You need to select the legacy dialog box, and then you need to select one sample KS. Here, you need to check only your continuous variable, not group variable. Uh, you need to select your continuous variable, and you need to put it into the test variable list, and then you need to click the OK button. You will find out that asymptotic sig2 tail value is greater than 0.05. So if this value is greater than 0.05, it means that you need to apply the paired sample t-test over here. So how can you apply the paired sample t-test? You need to go to analyze button, then you need to select compare means, then you need to select paired sample t-test. This is basically we are using over here. So you need to select this. Sorry, you need to select independent sample t-test, because both groups are independent from each other. So you need to select independent sample t-test. Paired sample is used when we are considering the Mayer twice case, when the groups are dependent on each other. In case of independent groups, we need to check independent sample t-test. So you need to select it. You need to put your continuous variable over here. You need to put your categorical variable over here. You need to define the groups, which is 0 and 1 in our analysis. You need to click OK, and you will find out this. So I have already interpret this table. The time is less than 1 minute to complete this session. So when the screen is off, you will join with the same link that I have provided you in your WhatsApp group. So please join.